In this video, we will learn how to create Grafana dashboards with a Python library called Grafanalib. We will also combine the library with Docker so we can create dashboards automatically when building a Grafana container. I've opened a directory on my computer to store all of our code for this tutorial. The first file I'm going to create is a prometheus.yaml file. In here, this is going to have the rules for what metrics the container should scrape. So I'm just going to have it scrape metrics every 5 seconds. And then for the location to grab metrics from, I have a single target inside of this job named Prometheus, and the Prometheus container is just going to scrape metrics from itself. This is just for demonstration purposes, and if you want to use a different target, you can change this line as needed. Next thing is I'm going to define the Prometheus container inside of docker compose.yaml. I've put a version at the top. As of late, I've been seeing that this field might be deprecated, so depending on when you see this video, you might not even have to put it anymore. The next thing I just added is a single definition for a container called Prometheus. I've decided to specify a specific image to recreate this in the future. Besides mounting stuff from etc, like the time information, I mounted a Prometheus YAML file, which is what we just defined. This is just a single argument to tell Prometheus what config file to use, which we've mounted here on line 10. And then finally, I've exposed port 9090 on my host so I can access the Prometheus UI easily. I saved the file, and then now we can run just docker compose up like this. We can see it's running. I'm just going to open Prometheus, and we can see the UI works. Some metrics that Prometheus scrapes from itself are information about the CPU seconds, which looks like this. This is just an instantaneous reading, I guess. But if we wrap it with a rate function, we can get, sorry, I forgot one dimension here. We have to do it by a time. And then if we do graph it, we can kind of see the CPU usage over time. This metric depends on how many cores you have on your machine and some other things, but usually it maps to a percentage of what the CPU usage is. So if I just keep pressing enter, we can see maybe the CPU usage was up a little bit, now it's back down, but all very low because Prometheus is more or less idling besides scraping itself for metrics. Another one that's interesting is you can do process network bytes. I'll just do transmit bytes. And then by hitting enter, you can see how much data was transferred over the network. I guess in this case, transmit as opposed to receive. So we'll be using these metrics in the next step when we build our Grafana dashboard. Next thing I'm going to do is define a basic Grafana container. So back in VS Code, I'm going to make a file called grafana.ini. And in here, it's going to be really simple. We're just going to say that our provisioning resources should all be found within the provisioning directory. This will all make sense when we define the container. And then I don't want to have any need to log in when we view the UI, so this just skips authentication. Back in our docker compose YAML file, I'm going to paste a definition for the Grafana container. So the most important thing to note here, when we mount our Python code, we'll be using this section, but for now I just want to make sure the Grafana container works. So I'm going to just put an image value here, and we'll just do Grafana / and then let's do version 10, like so. One volume we need to have here is that we mount the Grafana ini file into the container. And then down here, this is just a volume for storing some of the time series data and other things that Grafana has. And then I'm going to add a volume section here so that we've defined a volume to be used here for mounting that Grafana can use. So now I'm going to rerun this. So now Grafana is running. In a new tab, I'm just going to hit enter. And we can see Grafana is working. And we shouldn't expect to see any dashboards. So for example, if I go to the dashboard section, you can see that there's no dashboard defined. So now let's go ahead and learn how to create a dashboard with Grafanalib. So now let's go ahead and create another directory for our Grafana resources. I'm going to call it provisioning, which is similar to what we saw earlier. Inside of provisioning, I'm going to make two directories, one called dashboards and another called data sources. And inside both files, I'm going to make a file called all.yaml. So this is going both inside of dashboards and data sources. Inside my data sources all YAML, so provisioning data sources all YAML, make this larger. I'm going to paste where we're going to get metrics from, and this is from the Prometheus container. And the name, I'm just going to give it capital P Prometheus. Save that. Then in our dashboards, I'm going to paste a single entry in this providers object. So this is going to put all of our dashboards inside of a folder. This folder is visible from the UI. It'll just be called services. And then the path to the dashboards, which is going to contain JSON files. These JSON files will be generated from our Python code. We'll mount it into this directory in the container. And that'll be a step when we get back to our Docker Compose file. So in other tutorials, usually dashboards have JSON files in them, but since we're using Grafanalib, I'm going to only store Python code in here. So we can do something called example.dashboard.py, and this is going to contain some Grafanalib code that defines a simple dashboard. The first thing I'm going to import inside of our example dashboard py, see, so it's in provisioning dashboards here. It's going to be a few imports, so we'll make use of this in a moment. This is all from Grafanalib. I have a warning that this doesn't exist. Couldn't be resolved because I haven't installed it locally. This is fine because we're going to use Docker. All the code for this tutorial is in the video's description, by the way. Here's the data source name. It's P capital Prometheus. And then now let's create a dashboard. So this dashboard down here, it has a couple of parameters called title, UID. UID is used in the URL, so it'd be like localhost 3000/example, for example, lowercase. I just gave it a basic description, and then the time zone for data can just be in the user's browser, local time zone. The next thing I'm going to add is a single panel for CPU usage. I'm giving it a title as such. The unit can just be number format, which we imported on line 10. Grid position will be in the top left corner with an X and Y value of 0. I gave it a line width of 2. You can change this if you want to have more bold lines or more thin lines. This references the Prometheus data source name as our target, and then the query here is just querying the CPU usage, CPU seconds over this time dimension, and then passing it to the rate function. And then ref ID, this depends on how many targets you have. So if you have another target in this array, you change this to B, C, and so on. So everything has a unique ID. When you're writing Grafanalib code, it's important to have a single variable called dashboard. This is what the library references to create JSON. And this is usually assigned to a dashboard object like so, and then you call auto panel IDs at the end. So now that we've defined a simple dashboard in Python, I'm going to go back into our Docker Compose YAML, and I'm going to change this. Instead of being an image, we're going to reference a Dockerfile. And this Dockerfile is going to be in charge of building our Grafana container, which also includes the step of generating dashboards from our Python code. So I'm going to make a Dockerfile here. At the top, the first thing we're going to do is just import Python. The reason why I'm starting with a Python container is so that we have access to tools like pip. I'm going to install Grafanalib since that's a required dependency. I'm going to copy everything from provisioning dashboards into just a local directory at root. So /dashboards will have everything in here. The next thing I'm going to do is use a command line tool built into the Grafanalib library to go ahead and generate the dashboards. All the generated JSON files will be in this directory. Then in stage 2, I'm going to import Grafana. This container is going to be the actual container that we use when it comes time to run everything. So Python, we first use to generate our dashboards, and then we have a second image here. And this second image is going to pull results from the first in order to run. We copied our Grafana INI. Then what we're going to do is we're going to copy everything inside of data sources into this directory at C Grafana provisioning data sources. When I was working on this, I noticed that by clearing out the dashboards directory, it cleared any cache that Docker had, just to make sure that any changes we make in the first propagate to the second. So I just clear out this directory with rm-rf, and this just clears everything inside of dashboards. Now that that directory is empty, I'm going to first copy the all YAML file. The first time you run the container, obviously this isn't going to do anything, but running rm on a directory that doesn't exist is just a no-op. It doesn't raise any errors, so this is totally fine. This is when we're trying to rebuild the container. And then finally, we're going to copy our generated JSON files, which happens in this step. We're going to copy it from builder. We gave this first container a name builder, and we're going to copy all the JSON files into etc Grafana provisioning, and then in here dashboards. which we've cleared out with this step on line 18. Okay, now that we've done that, let's go ahead and go back here. We commented out the image step, and now we have a context and a Dockerfile. I'm going to go back here and just run up. So it looks like everything's running. Back in my browser, I'll refresh the page, and we can see there's a services folder. And you can open this up, example dashboard. There you go, CPU usage, very easy. And you can see the URL is /d/example, and then example-dashboard. So I guess the UID string came in here. Now let's go back and make a quick change to our example dashboard. So we have to keep in mind this grid position here because we don't want them to overlap. We want them to be distanced correctly. So I'm going to make another time series. It's very similar to the first. I'm going to change this to be network. I'm just going to call it network bytes. And at the top, let's use bits, as you can see here. Then down here, I'll change the unit to just be bytes. And then I'm going to have two targets to demonstrate that you have to change the ref ID. So then change this to B, and then let's go back to our, so this is process network transmit bytes total. So let's change this to be, we'll do both. And then the first one can be transmit, and then this one can be receive. And I have to change this X and Y. I'm making the width 12, so I guess the X value would be 12, but we can keep it on the same row. So now we have two time series, and I'll add one more. Let's add one more time series. So now there's three. You can see we have CPU usage, network bytes, and then down here I'm going to make the Y value 8, and then the X value can be 0. So now this is on the second row on the left side. I'm going to make it seconds, and this will just track uptime. Just have one target, and I'll go back on Prometheus. Let me see what the time is. I think it's process CPU seconds total, and then if you do time minus, yeah, this is the uptime here. So let's just use this metric right here. So it's in seconds. I think this all looks good. I'm going to go ahead and regenerate our Grafana dashboard, and let's see if our dashboard updated. Let's go back to our browser, and then here, as you can see, now we have 3 panels and they're all spaced evenly. Uptime doesn't look right. So if I go back here, I think we have to do process start time seconds. There you go. Yeah, now this looks like our uptime. But what's nice is that it's really easy to update this. All you have to do is just go here and then change it. I can even change this to be a stat panel. So I can change this to say stat. And then at the top, I'll go over here and import stat. This is a different type of panel. I think because this parameter has to be format. We also don't need line width, right? Can't just blindly rename time series to stat. Let's try again. So now Grafana is working. Let's go ahead and look at what we have here. Yeah, and as you can see, uptime is 3 minutes, and we have some information for network bytes. All very cool. I want to make a second dashboard just to show that it's really easy to add another dashboard with the way we've set up our Dockerfile. So I'm just going to call it second. And I think this one, let's delete everything but the last stat panel, just so it's simpler. And let's call it my second dashboard. Rename that. And let's just change this to have a grid position of 0. So now this is a second dashboard, very easy. If I stop everything, which I think this is now going to reset our uptime metric. If I rebuild Grafana, let's go back here. Let's go back to dashboards, refresh, everything loads services. Now you can see there's 2 dashboards, my example dashboard and my second dashboard. And there you go, there's uptime. If you want to change the color because it's gray, not very nice, we can add a threshold. And then the threshold for green is 0, so anything greater than 0 will be green. And then up here we can import threshold like so. So now you should have something like this for your second dashboard. All I did was add a new parameter threshold. It's an array, and then it has a single new import here called threshold. I'm going to rerun Grafana. Everything should work just fine. Let's come back here, refresh. There you go. It says it's been up for 3 minutes. Okay, so I think it's using the max value. So in order to get the latest value instead of the max, because this is inaccurate, we can add a new parameter, reduce calc last not null. This video is definitely not a complete Grafanalib tutorial. It's just to show you how to get started using Grafanalib with Docker. So once I add this new parameter, let's go back here and see what happens. It should just be a few seconds. Yeah, there you go. I think I just had to refresh the cache. So yeah, 15.1 seconds sounds a lot more reasonable. Refresh it a bunch of times, maybe about 5 seconds after it scrapes it again. We should get something like 20 or 25. Yeah, there you go. So it's updating. Yeah, it looks good. Just for fun, if you want to see the generated dashboard code, let's go ahead and create a shell into the container. So I'll just do docker ps grep grafana. We'll get our row for Grafana, so we can do docker exec-it, the container name, and then bin, and then I think sh should work. Yeah, we're in, and you can see just for fun what we're doing. We're in some sort of different OS because I'm recording this from Mac, and I'm definitely not on Linux. So now let's go see what the directory of our dashboards are. I can see that from the Dockerfile because we copied our JSON into this directory. So if I go ahead and here, and I do something like ls-l paste, you can see that we have 2 JSON files, example and second. And if I go ahead and cat, let's paste this, then second. It's going to be a lot, but let's paste it. Yeah, there's your generated JSON code. So it's a lot more easier to manage. When you make changes to your monitoring infrastructure, now it's just Python code to review instead of big JSON changes that are tough to review on GitHub. There you have it. Simple dashboards with Grafanalib.